If a man is in need of rescue, an airplane can come in and throw flowers on him, and that's just about all. But a direct lift aircraft could come in and save his life. That statement was made by one of the pioneers of aviation, Russian engineer Igor Sikorsky. Ever since childhood, he'd nurtured the dream of building a helicopter. But many years were to pass before Sikorsky succeeded in developing an aircraft that could hover like a hummingbird. Igor Ivanovich Sikorsky was born in Kiev on May the 25th, 1889. He studied at the Military Naval Academy in St. Petersburg and later at Kiev Polytechnicum. By 1910, Sikorsky had already developed his first two rotary airfoil aircraft, but the engines he used were not powerful enough to lift them off the ground. The principle behind the helicopter had been known for hundreds of years. It is documented that in China in the 4th century BC, there was a child's toy that already bore a close resemblance to a helicopter. 3 birds' feathers were attached to a wooden stick. When the stick was spun between the hands and released, it soared upwards. Children today love this toy, but just why is it able to fly? When an airfoil moves through the air, it divides the airstream into an upper and a lower part. Air, in fact, circulates around the airfoil. Under the airfoil, it flows against the outer airstream. Above the airfoil, it flows with it. The different flow speeds resulting from this have an effect on the air pressure. The air pressure above the airfoil is less than that below it. This produces the lift necessary for pulling the airfoil upwards. Angling the airfoil increases the lift. A stream of air around the airfoil is the basic prerequisite for lift. In order to take off from the ground, an aircraft generates this airflow through a high takeoff speed, but this calls for long runways. The airflow necessary for vertical takeoff, however, can also be generated simply by setting the airfoils themselves in motion. Leonardo da Vinci was already aware of this principle. Around 1483, he developed his helical air screw. It is regarded as man's first attempt at building a helicopter. This study inspired the design of many other rotary airfoil aircraft, but none of them proved viable. In the early 1920s, many of the pioneers of aviation tried to build a helicopter, but all attempts at vertical takeoff ended in total failure. Igor Sikorsky first focused on designing fixed airfoil aircraft. He developed multi-engined aircraft for the Tsar of Russia, which were also used as bombers in the First World War. In the aftermath of the October Revolution, Sikorsky was forced to flee to the United States. At first, life was hard, but as early as 1923 he set up the Sikorsky Aero Engineering Corporation, later renamed the Sikorsky Manufacturing Corporation, on a former chicken farm near Roosevelt Field on Long Island. In the years that followed, Sikorsky built large flying boats, among them the VS-44, the first passenger aircraft to make a non-stop flight across the Atlantic possible. But Sikorsky was still preoccupied with the dream of building a helicopter. By now he had engines at his disposal that were light and powerful enough, but there was another problem. As soon as power was applied to the rotor, a torque reaction spun the helicopter body about its axis in the opposite direction to the blade. So Sikorsky had to develop a method of keeping the helicopter stable. The world's first successful helicopter, the Focke-Wulf FW-61, combated the problem of torque with two counter-rotating rotors located on each side of the aircraft. In 1936, Hanne Reitsch demonstrated the aircraft in the Deutschlandhalle Stadium in Berlin. Precise hovering flight was possible for the first time, even indoors. But the big drawback with this system was the extensive outrigger construction. German engineer Anton Flettner came up with an alternative. He solved the problem of torque by designing a helicopter with two counter-rotating rotors which intermeshed like the blades of an egg beater. Its maiden flight took place in Berlin in May 1939. But Sikorsky had another idea. He hoped to stabilise his helicopter with a small tail rotor, which would pull against torque reaction and hold the helicopter straight. After a lengthy development phase, on September the 14th, 1939, the VS-300 lifted just a few centimetres off the ground. This successful test opened the door for the design of further control and propulsion systems. Stability, however, still proved a problem, as demonstrated in impressive fashion here by a light gust of wind. Sikorsky pushed ahead with his research until he was finally satisfied. On May the 6th, 1941, he took off on an attempt to break the world record for continuous flight in a helicopter. This was still held by the Focke-Wulf with a time of 1 hour 20 minutes. This handwritten sign told Sikorsky and the assembled journalists that the old record had tumbled. After 1 hour, 32 minutes and 26 seconds, he landed with 10 litres of fuel still left in the tank. On December the 8th, 1941, Sikorsky presented the VS-300A, seen as the direct forerunner of modern helicopters. It wasn't the first successful rotary airfoil aircraft, but it was the first to be controlled in line with the principle that's still customary today. It's a principle that gives helicopters like this exceptional flight characteristics. They can take off and land vertically, fly forwards, backwards and sideways, climb and descend vertically, hover and rotate about their vertical axis. A helicopter has three major controls: the collective, the cyclic and the pedals. For takeoff, there's no need to increase the rotational speed of the rotor. Instead, the angle of attack of all the rotor blades is altered simultaneously with the collective. Lift increases and the helicopter takes off. Movement of the collective is transferred to the rotor by a linkage. But how are control movements transferred from the fixed part of the helicopter, the fuselage, to the rotating part, the rotor? This is done by means of a swash plate, a large roller bearing mounted about the rotor shaft. The lower ring of the roller bearing is connected to the fuselage, the upper ring to the rotor via linkage rods. When the collective control lever is moved, the entire swash plate slides up or down the rotor shaft, altering the angle of attack of the rotor blades. To fly in a certain direction, the rotor disc, the circular area defined by rotation of the blades, is tilted to the appropriate side by means of the cyclic. This enables the helicopter to fly sideways or backwards while its nose still points forward. Tilting of the rotor disc is effected by changing the rotor blade's angle of attack. In forward flight, for instance, in forward rotation, each blade has a narrower angle of attack, so it generates little lift. But in rearward rotation, each blade has a wider angle of attack and thus provides substantial lift. As a result, the retreating blade rotates on a much higher plane than the advancing blade. This produces a forward inclined rotor disc, So in the course of one rotation, each blade is given one wide and one narrow angle of attack. The pedals control the tail rotor's angle of attack. This compensates for the torque, but if the angle of attack is reduced too much, it can no longer offset the torque and the helicopter will spin about its axis. On the other hand, if the angle of attack is increased more than necessary, the helicopter will spin in the other direction. The control possibilities give modern helicopters truly aerobatic flight characteristics, and thus make the helicopter the most versatile of aircraft. Helicopters have been indispensable in rescue operations and for use in mainly inaccessible regions. They're restricted only in the height to which they can climb. At high altitudes, because of the thin air, the rotational speed of the rotor has to be constantly increased in order to generate the necessary lift. That is why a helicopter can never fly as high as an aeroplane. The current altitude record for a helicopter is just under 13,000 meters. Another drawback with the helicopter is its limited speed. It can't fly as fast as an aeroplane. Maximum speed for most types is around 250 kilometers an hour, although some combat helicopters can reach 340 kilometers an hour. The reason for this is to be found in the movement of the rotor. Seen from above, one rotor blade advances towards the nose at a certain speed, while the other blade retreats towards the tail. In addition to the rotational velocity of the rotor blade, there is also the flying speed of the helicopter. The two combined can enable the forward-going blade to reach supersonic speeds, but that would give rise to an extremely dangerous situation, because at a certain point the air around the rotor blade would be compressed, generating a shock wave. The airflow would break away, causing the blade to stall, and the pilot would lose control of the helicopter. Yet, through their versatility, helicopters have proved their value, with the military too. Sikorsky's second helicopter, the R-4, was commissioned by the United States Coast Guard. In 1954, a dramatic rescue operation focused public attention on the successor model. An oil freighter had run aground in heavy seas. The storm was so fierce that the crew could only be rescued from the air. On 2 flights, the XR-5 managed to save everyone on board the vessel. Igor Sikorsky developed a large number of helicopters and played a major role in technical developments in this field. After offsetting the torque problem by means of the tail rotor, he began to build bigger and bigger helicopters. 1954 saw the maiden flight of the S-58 Choctaw, which could transport up to 14 people. It became famous under the name Seahorse. One of Sikorsky's most famous helicopters was the S-61. More than 1,100 were built. 1958 saw the introduction of the first Sikorsky helicopter that could land on water. With the Sky Crane, Igor Sikorsky finally ended his active career as a designer, but he continued to serve his company as a consultant for many years. On the morning of October the 26th, 1972, Igor Sikorsky passed away at his home in eastern Connecticut. He was 83 years old. Well over 1 million people in danger have been rescued by helicopter. Sikorsky's vision of developing an aircraft that could help people in need has become a reality.